Hello everyone, I'm going to introduce the experiment of measurement of air flow rate in circular ducts. The aim of the experiment is to compare various means of measuring air flow rates in air ducts. The standard methods for air flow rate measurement involve the use of pitot tube, venturi, orifice plates, nozzles, and various types of anemometers. They are in general different in working principles, accuracy, and ease of use. This experiment provides experience in the use of various measuring instruments and an opportunity to compare their accuracy. There are various means of measuring flow rate. The values of volumetric or mass flow rate measurements are often determined by measuring the pressure difference across an orifice, nozzle, venturi tube, or pitot tube. The principle of the method of measurement is based on the installation of a primary device, such as an orifice plate, into a pipeline in which a fluid is running full. The installation of the primary device causes a static pressure difference between the upstream side and the downstream side of the device. The rate of flow can be determined from the measured value of this pressure difference. This airflow measure range includes four main equipment, which is pitot tube, venturi tube, orifice plate, circular air duct. All these four equipment have been marked on this picture. This is the pitot tube. This is the venturi tube. This is the orifice plate. And this is the air duct. In addition, at the end of the duct is a damper. The pitot tube, in conjunction with a suitable manometer or differential pressure transducer, provides a simple method of determining air velocity at a point in the flow rate. In this picture, the pitot tube has been connected to a manometer. In addition, here provides two useful formula for pitot tube. The first is about the volumetric flow rate for pitot tube, and the second is about the velocity pressure. For the venturi tube or orifice plate, they also need to be connected to a manometer. Here, useful formula for venturi tube or orifice plate are also given. They are all about the volumetric flow rate. Here I'm going to introduce the procedure and the stage of the experiment. The main procedure of the experiment is record the dimensions of the air duct and then start the fan and close the air damper. At stage 1, you need to connect the anemometer to the pitot tube. Then open the damper slowly and place the pitot tube at the middle of the transparent test section such that the anemometer reads 3 meters per second. Then use the pitot tube to obtain 9 velocity pressure readings at the test section in the following pattern. A. Along the upper plane, there are 3 points. B. Along the mid plane, there are 3 points. C. Along the bottom plane, there are 3 points. Then record all readings in a suitable table in your logbook and calculate the average air velocity in the duct. Obtain and record the static pressure drop across the venturi and the orifice. Calculate the volumetric air flow rate for measurements obtained using the various instruments. At stage 2, you need to adjust the airflow rate by opening the damper so that the anemometer readings increase in 2 meters per second style until the damper is fully open. Then repeat the Peter tube, venturi, and orifice measurements, and repeat 1.2 to 1.4 above. We need to turn on the power first and start the fan. As I introduced before, at the end of the duct in this range is a damper. And after we start the fan, we need to close this damper. The anemometer needed to be connected to the Peter tube to obtain the air velocity in the middle of the air duct. Then we need to open the damper slowly to make sure the air velocity in the middle of the air duct is 3 meters per second. We can read the air velocity from the anemometer. Then we need to use the Peter tube to obtain 9 velocity pressure readings at the test section in the following pattern. There are 3 points along the upper plane, and 3 points along the mid plane, and 3 points along the bottom plane. Here is the location for these 9 velocity pressure readings. At the same time, we need to obtain and record the static pressure drop across the venturi and the orifice. And after all this work has been done, we need to adjust the airflow rate by opening the damper so that the anemometer reading increased in 2 meters per second step until the damper is fully open. Then repeat the Peter tube, venturi, and orifice measurements. We need to summarize on the results we obtained in the experiment in a suitable table. And then last we plot the airflow rates for Peter tube, our venturi tube, our orifice plate in a graph. Well, that's all for this experiment. Thank you.